Today's lesson, which continuation of this, which is going to be called solving inequalities. Now we've done some of this already. If you are fading out of today's class, now's the time to fade in because this is tremendously important. Okay.
You say that every class.
This is though. Step away. 2 over x minus 5 is less than 10. Now here's the thing, right? And this is the thing you have to be very, very aware when you're doing this one, all right? You cannot just multiply both sides by x minus 5. Okay? The reason for that is, if you think back to solving inequalities from grade 11, okay? I'm not sure if everyone did it in grade 11, I know we did, okay? What happens when you're solving, like, what happens when you solve that equation? What do you have to do, Tristan? Right?
You divide the negative through the sign changes.
Right on. Okay, so if you're dividing by a negative or multiplying, the greater than and less than signs flip, right? So this is actually going to make a difference for this equation. If x minus 5 is positive, then this inequality sign is going to stay the same. But if x minus 5 is a negative number, then it's actually going to flip and it's going to be greater than. Okay, so we're going to avoid that whole conundrum and just solve it like this. Okay, so we're going to say you can't, I'll put this in red, you can't just multiply denominators, and I know you will all want to. You have to solve this equation. You're probably saying, oh, Mr. Sadler, algebra, I love it, and I'm glad that you're thinking that. Okay. What did I hate there again? Okay, so Kylie, how do I do, let's forget about the right-hand side. When I do 2 over x minus 5 minus 10, do you recall back from grade 10 or 11, how I do 2 over x minus 5 minus 10, how do you do that? You do it to find a common denominator, very good. What's my common denominator going to be? Very good. So we're going to call this 2 over x minus 5 minus 10 x minus 5 all over x minus 5 less than 0. Okay, so you see what I did there, right? I multiplied the denominator. I should probably put it in here somewhere, x cannot equal 5. Because that will actually going to need in a second now. Okay. All right. Can you please simplify the numerator? What's negative 10 times x minus 5, please? Great. So that's going to turn into negative 10x plus 48 all over x minus 5. All right? That was right to make. Make a mistake? 152. Oops. Thank you. Okay, so this is the thing. How do we solve this? The options that we have here are to graph for these interval chart. Those are the 2 options. Okay. What do you guys want to solve? Graph and interval chart. Interval chart? Wow. Awesome. Graphing and interval charts. Okay, so the points, if you use an interval chart, the intervals will be vertical asymptote and x-ints. Why would the x-intercept matter for the interval chart here? Is that a question you guys should answer? Go. Why would the x-intercepts matter for the interval chart here? Yeah.
Because that's going to be like, your graph is going to be one of your quadrants. X will tell you your quadrant.
Right on. Okay, right? If my graph, let's just, you don't have to draw this down here, okay, right? But if this is 0 and I have an asymptote here, right, that's going to tell me, this is going to be the point that tells me if it's above or below, right? Okay, so the key points that I'm going to use are my vertical asymptote and x-intercept. So let's start off here. What is my vertical asymptote here, Brian? What's my vertical asymptote? for this graph, please? Yeah, so x can't be 5. My x int here, Bailey, is going to be what? Oh, sorry, now you're solving this, right? Right, so. Okay, good. So, here I'm where I got that from. So we do the same thing we did before with our intervals. Here we go. So I'm going to write f of x here. Can someone else tell me what to write south of f of x? What am I going to write there, please? What's going to go underneath that? Go ahead, Alana. X minus 5, good. Anything else? Okay, somebody help her? What else is going here? Okay, guys, I know it's Wednesday, but we gotta wake up here, please. I want to go.
There's the negative 10x plus 52.
Wow. Okay. Now for the tricky part.
So why don't we need the horizontal asymptote for loss of
Okay, because if you think we're only looking for when the graph's, since we've dealt with the graph being bigger than 0, 0 is the only thing that matters. Okay, whether the graph's above or below a horizontal asymptote of 5 doesn't really matter, right? Because if it's below 5, it's still going to be still above 0 for a certain part of it, right? Okay, so that's the only
when it's less than 0.
right on. Okay.
So if it's greater than 0, it would just be the same thing.
Right on. Right on. Okay, so what are my intervals going to be? What's my first interval? X less than? X less than 5. Okay, second interval is going to be what, please? Somebody else? Yeah, go ahead.
5 is less than x is less than
Yeah, well, which is going to be this, 5.2 right on. 5 is less than x is less than 5.2. And then x is greater than 5.2. Okay, my test point here is going to be easy, 0. Here I'm going to pick 10. What is a nice solid number between 5 and 5.2? 5.1 is a beautiful number right in between there. Okay. Now, it says this graph we want to have less than 0. So what are our successes going to be when our overall is? Overall is less than 0, which is negative. Okay. So I'm going to sub these numbers in here right now. Okay. I'm going to sub in here. 0 times 10 is 0, plus 52 is a plus. 0 minus 5 is a negative. My overall here is negative. Okay. I'll do this one on the right next because it's easiest. 10 times negative 10 is negative 100, plus 52 is a negative. 10 minus 5 is a plus, that's also going to be a negative. 10 times 5.1 is negative 51, plus 52 is a plus. And 5.1 minus 5 is a negative. Is that right? Whoa, goodness me, attack mode, thank you, class. Are we good beyond that? We're good beyond that? We're good beyond that, right? Okay, good. So we want to when this graph is less than 0. Therefore, what you're looking for is x is less than 5 and x is greater than 5.2. That's your solution right there. I have one more example. 2 more examples?
Negative portions or something.
Okay, are we sort of okay on that? Before I continue? Go ahead. Question. So basically what you're just doing is here, it's the same as we were doing before, like for the solving greater than less signs, but we're going to use our vertical asymptotes as one break and our x-intercept. That's all we're doing. Yeah.
Hey, what's my best? Do we have to go very
Do that. I'm going to do interval chart because we're going to get on to the next one with variables of the gap. So you can do any polynomial divided by any polynomial, and it's always easier to do with interval chart, or you will find it. Okay. And then leave the option up to though that you made. Okay. All right, example 2. Okay, I'm even going to start this easy for you. Okay, I'm going to say solve.
Wait, did you show them why that works at the end of the day?
What's that? Well, which works?
At the end of looking at inequality, right? Like the x minus 5 is less than 10. Is that 5.2, right? Because you put 2 over
Oh, okay.
5.2 minus 5. You get 2 over 0.2 equals is less than or equal. Right?
So that would work.
So it has to be before that.
Right on.
So it has
Yeah.
to be.
Yeah, and that's the idea, Nick.
That's it,
That's,
yeah.
and Nick, that's the idea with these test points, right? That's sort of
Yeah,
turning
yeah.
into, that's leading into that, right?
Okay.
So x squared plus x minus 12 is greater than. Okay, so you guys will get this on the next test. Okay, and somebody will freeze. Hopefully it's not you, Brian, or anyone else in the class. Okay. Adrian, I'm going to pick on you because I think you're where Spider-Man should be right now. Adrian, whenever you see a question like this, what should you instantly want to do first, no matter what? Factor. Can you factor the numerator for me, please? Yeah, negative 2 and then x plus 1. Okay, Elena Waller, can you factor the denominator, please?
Positive 4.
Okay. Lana Lawrence, the two things we need for this are our x-intercepts and our vertical asymptotes.
Two vertical asymptotes, 3 and then 4.
Foxton, what are my x-intercepts, please?
I gotta look.
You don't have to look, or you won't learn not to look. Where did I instantly get 2 and negative 1 from?
Oh, it's just
Right on the numerator, right? Like, because if you think, if you want it to equal 0, either part of the numerator has to be 0, right? So it has to be 2 and negative 1. Okay, now I'm going to take a slow down here because I'm getting too excited.
Are you?
Yeah, no, because they're not catching up to me. I just make a joke like that to make them giggle, okay, but really,
Wait, why?
I'm bored out of my mind, but I want, this is too easy for me. I need No, okay, sorry, go ahead. Because what you're saying here is if, just pretend this wasn't here, right? You want the numerator to be 0. These are like your roots in the numerator, right, or your x-intercepts. Okay. All right, so we're going to graph this one after, too, just to show you what it looks like, because I'm curious, too. All right, so let's do an interval chart here right now. So I'm going to start with f of x. All right, Owen, can you be brave, please, and tell me everything that goes in the f of x chart, please?
So x minus 2, x plus 1, x plus 4, x plus 3.
Wow, x plus 1, x minus 2, x minus 3, x plus 4. Now, this is the time to ask questions. Okay, so where did Owen get all those from? Anybody else here? Can somebody tell me where Owen actually got all those things from? Fox and go.
The equation.
Yeah, these are the 4 parts of the equation. All right, so if there's something you can't factor, we'll deal with that in the next few examples, okay? But it's possible you meant to use quad formula or something in there, like you had to on your test. Yes, go ahead, Joe.
Is there anything with horizontal asymptote?
There are, but not for inequalities. Like for inequalities, you don't need to worry about the horizontal asymptote.
Just use the coefficient thing again, and then
Yeah.
you'll get the same, you'll get 1.
Yeah.
Because your coefficients
So we're going to graph this one in a minute here once we're done this, just so you'll have those there, okay? Now, as far as my inequality goes, what's my first inequality on the next? What's the first range going to be? Brian, go. X is less than negative 4, very good. So what Brian did, I hope, he can tell me if he did, he looked at the numbers, picked the smallest number, and then said lower than the smallest number. Okay? Can someone else other than Brian, thank you, Brian, tell me please what my next interval is going to be? ahead, yes. Right.
So, negative 4,
Yeah.
x is less than, or greater than negative 4 plus 3.
Tell you what, yes, I can't even count. Okay. Perfect. Okay. Thank you for my 2 volunteers. Can I get a 3rd volunteer? Bravely volunteer me the answer. Yeah, go.
Some negative 1's less than x less than 2.
Great. Now I have to go to the next board here. And my last one should be, what's the next one? There are 2 more? There's 2 more. What's the next one? Somebody else? Please? Is that Albert?
X is greater than 2.
Yeah.
Is greater than 3.
The next one, yeah, 3. Good. And finally, we're going to have x is greater than 3. Oh my gosh, this is so cool. I'm with you. I've never seen such an awesome thing. Wait until we graph this. And think this is wicked. Wait until we graph this one. Totally. This is in grade 11. I almost said this is grade 11. This is grade 12. Oh my goodness.
Is it graphing calculator?
We actually, you guys look at that.
You haven't seen that book. No, you've seen that book.
Oh, yeah.
All right, here we go. So what I'm going to do is I'm going to pick a test point less than negative 4. That point can be anything. I'm just going to choose negative 5. Here I'm going to choose negative 2. Here I'm going to choose 0. Here I'm going to choose 2.5. And here I'm going to choose 11. You can choose any numbers in those ranges as long as it works. Please take care to make sure that they actually go where they're supposed to go. Okay? So then I'm just going to fill in the chart. Negative 5 plus 1 is a negative. Negative 5 minus 2 is a negative. Negative 5 minus 3 is a negative. And negative 5 plus 4 is a negative. Negative, 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 make it positive. So far so good? Sure, we're good? We've done these interval charts tons, I hope now. Negative 2. Negative 2 plus 1 is a negative. Negative 2 minus 2 is a negative. Negative 2 minus 3 is a negative. Negative 2 plus 4 is a plus. That's going to be a minus. 0 plus 1 is a plus. Then a minus, then a minus, then a plus. 2.5 plus 1 is a plus. 2.5 minus 2 is a plus. 2.5 minus 3 is a negative. 2.5 plus 4 is a minus. And plus, plus, plus.
Just to point out too, understanding when these functions are positive and negative go a really long way. Not just here, but when you take calculus and other things. Looking at what functions when they're positive and negative is like one of the biggest things you can do. It's huge.
So you're saying this might be important for them to do with 3 stars? Like I said at the beginning of my lesson? Totally.
Absolutely.
Put stars on it?
Oh my goodness. Didn't you hear when I said it? And Alanda's like, every example you put star beside Mr. Sadler.
No, I said,
So this one has 2 stars. This is
it's
2
like
stars.
fundamentally important. No, you're.
All right, so the answer for this one is going to be, I want this to be positive. So we're going to have x is less than or equal to negative 4, negative 1. All right, why in this case do I put the less than or equal to signs instead of just the less than signs? Peter?
This is also on like the original inequality, like less than 3. Right on.
Okay, so I am going to actually graph this for curiosity's sake. Okay, so I have all my interval charts. I know it's going to be positive and negative. Just to summarize, I had my vertical asymptote was that x cannot equal, what numbers here now? I lost them now.
Negative 4 and 3.
Negative 4, comma 3. I had points at,
Just for fun, your horizontal is 1.
yeah, and I just want to make sure that everyone sees why the horizontal is going to be 1. If my original equation was x squared minus x minus 2 all over x squared plus x minus 12, okay? If you take a look, go ahead, please. If you take a look at the horizontal asymptote, it's going to be the coefficient of the lead. They're both degree 2, so the coefficient of the x squared divided by the coefficient of the x squared. So it's 1 divided by 1 equals 1. I'm going to graph this up very, very quickly just to show you this is what it looks like. And I should probably also get my y-intercept is going to be 0 and 1/6. Where did I get the 0 and 1/6 from? Other than that. So x equals 0 in there, right? So everything is cancels on. So for how this graph is going to look, it's going to be awesome.
Do the function increasing and decreasing?
Yes. Don't confuse them though. They're not a calculus yes. Okay. That is a tremendously important thing to learn for next year or for next semester. Although after this course, they're all going to say, I don't want to have Mr. Sadler as a teacher, so that'll be good.
You just gotta get through it.
You laugh, but the hate is real.
Can we just do like a rough sketch?
Yes, rough sketch, okay. But on your test, you don't have to do this for real, so
I always rough sketch. I never do it for.
don't be like my head back. All right, so let's go through how this graph's going to look. I have a horizontal asymptote right here. I have a vertical asymptote at -4, which is here, and 3, which is here. I have a y-intercept at 0, 1/6, which is right here. I have a 2, 0, and -1, 0. Yuck.
What the?
Is that right?
Is it?
Yuck.
That doesn't work, right? Doesn't it? It's always positive.
What's up there?
Is the function always positive? Or is it negative at some time?
Oh. Well, the slope will be decreasing, right? The slope will be decreasing. Yeah. Okay, so that's all I know. Okay? What I would do then is I'd plot another point up here, and these should end up like this. Now, so make sure that it goes to the values that we wanted. It said our values are positive when x is less than -4, which it is. What's that?
The ones, the what?
Oh, 1/6 is right here. It's 1/6. Oh, because I just have x equals 0 in here. 0, 0, 0, 0, -2. Okay, so let's go through to make sure this makes sense according to, according to our solution here. You said x was positive when it's less than, I said less than or equal to, I should have said less than though because the asymptote says x cannot equal 1/4. Between -1 and +2 it was positive, and then also greater than 3. Alright, so there's your, what the graph of that would look like. That should look familiar to you because it looks a lot like the graphs we did last year in grade 11, except for the asymptotes were right on 0 instead of, yes.
So I still don't get why you don't use a horizontal asymptote, like, for this.
Because the point is for the horizontal asymptote, it doesn't affect the 0 at all, right? Okay, like we know that, right, so these ones are above the horizontal asymptote on the left. Right, but whether this is 1 or 4 or whatever, it doesn't really matter, right, as far as that goes. Like the entire graph is above that over there, right? So what we did is we checked a point over here someplace. We checked a point here in the middle, we checked this point, and we checked this point, and we checked this point. That's what we checked. So over at -6, wherever I picked, we had a positive value. Okay, at -3 or -2, we had a negative value, which is down here. At 0, there's positive. At 3 over, or 2.5, wherever we picked here, negative. And then 6 or whatever is positive, right? So the asymptote doesn't affect the positive and negative. It just affects sort of how the graph's going to go.
It just affects where it's positive and negative, right?
Yeah.
Like it is important, but like for this, trying to just learn this stuff is
For the greater than less than part, it's not actually the side. All right, do you guys want one more? You clearly don't, but all right, homework. Homework?
Yeah.
This is so easy. It should be so. Is that what you said? It should be so easy. This is why this course is easy. This is when you guys, I say to you guys, grade 11, 12 is easier than 11. It is.
Have you done trig yet, or you do that?
That's,
Trey is coming next. Homework, page 184. Number 4, 5, 10, and 16. As well, it was also 183. No, number 2, 9, and 18. Yeah, so this is the first stuff was 183, I think. That's, I think that's all actually, it's probably 2, 4, 5, 9, 10, 16, 18, probably all in the same section, I would think. All right, if you need to borrow a book, let me know, I can arrange that for you. Oh yeah, somebody said to me, yeah, this is easy, okay? Once you do a few of these